Hello friends, welcome back to my channel. And in continuation of our previous lecture, um, in which we just discussed the static indeterminacy of trusses, and we got an equation which was static degree of static indeterminacy, and we got it by subtracting number of knowns from number of unknowns. So number of unknowns we had, number of members, because we want to know how much amount of load is being transferred through them, and we didn't know the value of support reactions, which are R. Then these combined are unknowns, and the things which we already knew about the structure are there are definite number of joints, and each joint have two equilibrium equations associated with it. So combining these two terms was the excess or deficiency of the equation required to get a solution which means evaluation of support reactions and the forces which are being transferred in the members, okay, with the help of 2j number of equilibrium equations. If it is excess, then it is positive, okay. It could be three numbers. There could be three possibilities. Either it is negative. If it is negative, then it is unstable, because equilibriums which are required to be maintained are more, and structure is not adequate to maintain those equilibriums, which makes the structure itself a unstable one. Okay, so this is the theoretical method by which we can determine whether a structure is stable or not. In other case, it could be a zero. If this is zero, what will happen? We have all the unknowns, and all the knowns are equal in number. It is as simple as calculating x plus 9 equals to 13, because we have one number of unknown and there is a one equation. So it is easy. That is known as determinate case. Determinate structure or determinate case, okay. And in third one, it will be a greater number which will be a positive, and that will be our trouble. Not a trouble but difficulty, because higher the number of this, higher the degree of static indeterminacy, larger will be the additional equation required to get these m plus r, all the unknowns, okay. See, if I give you example, a plus b equals to 97. What is the value of a? You can't tell until you know the value of b. And if I specify you the value of b is 1, then I provided you a one more equation, and that's how you got two unknowns with two equations, and that makes it determinate. Two unknowns, two knowns, and net is 0. Determinate, okay. So a plus b and b, these are two equations, but if I didn't allow you this equation, I didn't give you this equation, then you need one more equation, and that is the trouble. That's how for that we need to do some extra work to generate those equations, okay. And that type of structure is known as indeterminate okay, truss or structure, whatever you are talking about. In this case, we are talking about all about trusses. So in continuation of a lecture, we got this degree of static indeterminacy, which were we discussed in force method. There is one more method for analyzing structure, which is displacement method. What is that? In displacement method, we we do consider a complete structure in such a way that we what we do in displacement method, we examine or calculate the deformation displacements. We calculate or examine the displacements and estimate, and then estimate the amount of loads which could be allowed on the structure, loads and reactions, so that we can make a structure strong enough to provide such reactions and transfer those loads. Okay, we do that in displacement method. First we calculate the displacement or deformations, and then we correlate them with amount of load which needed to be transferred through that cross section, and supports with sufficient strength to provide such reactions. So in displacement method, what we should focus on, that all the joints will get two support uh, two degree of freedoms. It can move in this direction, it can move in this direction, each and every joint, until unless that joint is a support. Then this is a hinge support, so that this joint cannot move in this direction, cannot move in that direction. It is our assumption if our support are strong enough. And suppose this is a ruler support, then this joint cannot move in what direction? This direction, because this will get a reaction, but it is allowed to move in that direction. So we got the number of joints, and with each joint there are 2 degree of freedoms where it can move. So we have 2j number of degree of freedoms for each joint, but there are some joints which are not allowed to move, or they are not free. So what are those degree of freedoms which are reduced now? Are this support reaction, it is not allowing this node to move in vertical direction as well as in horizontal direction, and so there are 3 of these restrictions on overall structure, and I can just tell them this, that this support is support reaction is, say, R1, this is R2, and this is R3, and all of them are in number R. So all the joints which have degree of freedom 2j minus, which are the joints what which are supported, then there will be net degree of freedom, and which is known as kinematic and degree of kinematic indeterminacy. Okay, this is known as kinematic indeterminacy. Suppose R is here we can calculate R is 3 in numbers and J is 2, 1, 2, 3, 4, 5. 5 joints. Okay, so there will be 10 degree of freedoms and minus 3 reactions. So there will be kinematic indeterminacy will be 7. 2 into 5 minus 3 is equal to 7. Okay, so this is kinematic indeterminacy. Okay, in order to solve a structure with the help of displacement method alone, we need 7 more equations. That's why it is difficult method, because we need 7 more equations to just to get members. Whereas if I can apply method of force method, then there will be support reactions. How many there will be support reactions? For this example, DSI will be M plus R. What are they? Say this is M1, this is M1, M2, M3, M4, M5, M6, M7. These are 7 members with the joints 1, 2, 3, 4, 5, with 5 joints, and support reactions they are 3. So our M plus R minus 2J will be equal to MR7. Support reactions are 3 minus we have 5 joints and which is multiplied by 2, and this gives us a value of 0. 7 plus 3 10 minus 2 multiplied 5 equals to 10, and DSI is 0. It is statically determinate, and that's why it is a easy method, because you need not any extra equations to get the answer. You have sufficient number of equations to get the all the unknowns, these member forces and these support reactions. But if you apply this method, this will require 7 more additional equations. So with the help of this 2J minus R, which is D degree of kinematic indeterminacy, and M plus R minus 2J, which is degree of static indeterminacy. These two are two numbers. Okay, M plus R. Okay, we get an idea that if this number is more than this number, means if I just have to make a decision, if DSI is greater than DKI, if it is yes, Yes, this degree of static indeterminacy is greater. Then follow which method? If degree of static indeterminacy is greater than degree of kinematic indeterminacy, then only follow displacement method. Okay, displacement method, because that will give you easier, that will use lesser generation of additional equation. Remember, if it is low, whichever number is low, prefer that method. If if it is no, either it is 0, either both number are equal, then we need a one more decision. If dsi equals to d degree and degree of kinematic indeterminacy, if both are equal, and then you have choice, choose your favorite one. Why favorite one? Because you will be faster in that method. It's your choice. If both methods are, if both method have both degree of indeterminacy, both have same value. But if it is yes, then this. Yes, both have same, then choose your best one. Otherwise you got no. If it is no, neither degree of static indeterminacy is greater than kinematic indeterminacy, nor degree both, nor they are equal, then follow force method. Okay, then follow force method. And force method we already discussed. This gives, force method gives degree of static indeterminacy, and if it is lower than this number, it is lower than this number, then follow force method. And if it is if kinematic indeterminacy is lower than this number, whichever is lower, follow that method. And in case they are both same, then choose your favorite one, because that will take lesser amount of time. Okay, so till now we have discussed so far so many things, and I think it is a good time to get some problems. I have solved many problems in my other videos already. You can check it out them, and I will put a description of that video in my description of this video. I'll post that a link which where you will get some solutions, and there will be some problem set and whose solution will be available on my blog website. Below them you can try to solve those problems. If you want to check the answer, then you can follow the description and get to my blog and see the answers, and you can check them. I think I have solved 8 examples with this, and with calculating both of degree of indeterminacies. So there will be 16 numericals, and you should do that. And if you are good enough to get the answers, or you get the confusions regarding any problem, you can just comment that particular problem. I'll explain you in either in separate video, or just in below the comment, or I'll give you some resource, whether it could be a photograph or anything which I could post in the comment box. And let's take one more example if you like. Okay, so we have already discussed about um, the various type of trusses. The simple truss, which is made up of simple connect making by connecting some triangles. Okay, you can make any kind of structure you wanna know, you wanna create. Okay, any type of structure. You show your creativity, how good you are in creating such things. Maybe this could be any structure. Hmm? So this is an example of simple truss. Okay, so we can get a complicated truss or compound truss, and complicated truss is also known as complex truss and a compound truss. So what is a compound truss? Compound truss is the combination of two simple trusses like this I just made, and I just show you that one more. And this I am just making a shorter version of this. Sorry. Okay, just this, and maybe they are to join with another. I just want to construct it symmetric, but I think I didn't did it well. Maybe this. Oh, okay. I just wanna make sure that each and everything is connected with triangles. So I just extra added this part. This part need not to be added, but you can imagine that this type of shape is repeating in this, in just symmetric and in mirror image. In other fashions, you can add some other kind of members with the simple truss. You just made this and add these elements together. Just make sure that you are using just triangles. Then these two shapes are connected together and they are compound truss. They are combination of two simple trusses. Okay, this is simple truss, this is compound truss, and we have for complex truss we got our spatial structure. Remember, the members were pinned at these points, but other points were, but these points are just crossing each other, overlapping each other, no? These members, okay? So, so this could be a complex truss. I have solved many examples of all these types in my that video I'll put in description, and there are problems and their solution is also available. I have already told you that. So what next is, I'll just take any one example, any one, say any, or just write a one, and I'll show you how to calculate the static and kinematic indeterminacy for that. Okay, so let's take an example. Hmm, yes, this. Okay, yes, this is suppose this is a, suppose this is a structure. It could be anything. I'm just making it this way, although it is difficult, but just just for the sake of complexity or the difficulty, I'm just making this way. Or I can just make one more member this. You won't see this structure in popularly. I'm just complicating and just following my head. Okay, so assume this is a structure, although it is not looking like the familiar structures, but let's say this is a truss. We need to determine its degree of indeterminacies, and both of them, whether it is static or kinematic. Okay, okay. So these are two types of degree of indeterminacies. So we know that it is m plus r minus twice of j, and this is equals to twice of j minus r. Okay, so we have how many members? Member 1, member 2, member 3, member 4, member 5, member 6, member 7, member 8, member 9, member 10, member 11, member 12, member 13, member 14, member 15. Okay, these are 15 members. Okay, okay, good. And so much okay. And how many joints we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have m equals to 15, j number of joints equals to 9, and support reactions 1, 2, all these are hinge supports, 3, 4, 5, 6, 7 and 8. Support reactions are 8. So we have these three numbers: number of members, number of joints, and number of support reactions. Now we can calculate these two quantities easily. 2j minus r, twice of j, which is 9 twice 18, minus r, 2j minus r, 18 minus 8 is equals to 10. 18 minus 8 equals to 10. and we have degree of static indeterminacy is equals to m plus r minus 2j. 15 and 8, 23. There are total unknowns minus twice of j, and which is twice of j means twice of 9, and which is 18, and it is equals to, hence it is equals to 23 minus sorry 8, twice of j, twice of 9, twice of 9, twice of 9. Okay, and 15 plus 8 equals to 23, and minus 18, 23 minus 18 equals to 5. See, we use so many supports and with so much restrictions, our degree of static indeterminacy came 5, and degree of kinematic indeterminacy came 10. Okay, so in this method, by this analysis of equations, we could easily say that degree of a static indeterminacy is less than degree of kinematic indeterminacy, so we will prefer this method. It is smaller than this one. And one more important observation, and that is what I have mentioned it in my blog. I will post that link also in description, where I just uh, luckily got an equation. What that equation was? Okay, that was, we know that m plus r. I never read this in any book so far, and I just searched for it in internet. I didn't get any link for that. And what is that? M plus r minus 2j is static indeterminacy, we know that, and 2j minus r equals to degree of kinematic indeterminacy. Getting? These are two numbers. Okay, so what happens? I never read this book never read this relation before, and this thing came into my mind. I just added these two equations. Nobody did that before, in my knowledge. So dsi plus dsk equals to what it comes to this side. Okay, let's see. And we are subtracting it, means the 2j will be negative and r will be positive. Then we see there will be some m, because m is not being reduced here, and we will have plus r, and okay, did I get mistake? No, 2j minus r. Okay, oh gee, the sign will not change. Oh, sorry, uh, I forgot, we are just adding, not subtracting. Oh, okay, so sign won't change. This is plus r, and this one is minus r. So what will be net? There will be 0 of r. And what is this? 2j minus, and this is 2j plus, so we got another 0. And what? We knew a relation, dsi plus dsk equals to what? M. The sum of degree of static indeterminacy plus degree of kinematic decay DKI, kinematic indeterminacy, the sum of DSI plus degree of kinematic indeterminacy is M, number of members. Isn't that wonderful? You just calculate one, know the number of members, and you will get the value of other one. Isn't that simple? Yes, it is. So I hope you like this video, and if you like it, then hit a like button. If you dislike it, then hit a dislike button. I haven't seen any dislike button in my channel till now, but it wouldn't mean anything. It would mean something if you didn't like it, or I need improvement, or you can comment in comment box whatever thing you wanna say to me regarding this knowledge and this teaching, um, and if you think it is good method for us for others to that it could be helpful for them, then kindly share it with them, and just ring a bell behind just side of subscribe button, so that you can get the timely notification. And in future, in other lecture, I will teach you some fundamentals about the frames, and might be before that we will analyze a truss by by this method, degree of static indeterminacy, and the force method. We will analyze maybe some simple truss, and compound and complex one. Complex one takes a little bit time and little bit trick, but you can solve that also, and we can also. And I'll just show you method, okay? And might be we take one or two examples, and that will be under the structural analysis of trusses. After that, we will switch to some other structure, maybe that frame or any other. Okay, so hope to see you. Stay connected. Thank you.